Hello everyone. Welcome back to Solid Geometry series. Today we wrap up with orthogonal relations. Um, so hopefully with this last video on orthogonal relations, you will have enough um, to feel confident about these topics. We will encounter problems in orthogonal relations again randomly in the future, but um, will be at a higher degree of difficulty, right? Um, so today, the problem I have for you is let S.ABCD be a pentahedron with square base ABCD, and SA is perpendicular to the base plan ABCD. H, I, and K are the projections of A onto SB, SC, and SD respectively. A, determine the angle formed between SB and AD. B, prove that AH is perpendicular to SC and AK is perpendicular to SC. And C, prove that HK perpendicular to plan SAC, and from there deduce that HK is perpendicular to AI. Feel free to pause the video if you want to give it a try. Otherwise, continue watching for the solution. Okay, part A, the angle between SB and AD. Because ABCD is a square, and so BC is parallel to AD, right? So the angle between SB and AD is the same as the angle between SB and BC. But we know that BC is perpendicular to SA and BC is perpendicular to AB. And therefore, BC is perpendicular to plan SAB. Consequently, we have SB is perpendicular to BC. And as a result, the angle between SB and BC is the angle SBC, which is 90 degrees. So hopefully part A is straightforward for all of you. Now, I realize that this is the angle question, so it's not really orthogonal relations, but in the problems, there can be a mix of multiple questions. But for the most part, this is still an orthogonal relation problem, especially when it comes to part B and C. So please bear with me. I also realize that this time I'm going faster than normal because, for the first 3 videos, I have, been slow enough to explain everything in details. Like in this case, how do we have BC perpendicular to plan SAB, right? If you feel like you are struggling, in terms of understanding that orthogonal relationship, it will be extremely helpful if you revisit or if you haven't watched it for the first time, watch the first 3 videos. It will help you a lot. Okay, moving on to part B. We need to show that AH is perpendicular to SC and AK is perpendicular to SC as well. If you watched my previous video, you should recognize that this question is very similar to the question in that problem, but with a little twist, right? So instead of explaining everything in details, I strongly encourage you to look for video number 3, the one immediately, prior to this one, and watch it, because it's basically, same solution. So the idea is that you need to show BC is perpendicular to plane S.AB. Okay, then from there, we have AH is perpendicular to BC, right? But at the same time, we have AH is perpendicular to SB, and so therefore AH is perpendicular to plane SBC, and consequently, AH is perpendicular to SC. And repeating the same ideas, we can deduce that AK is perpendicular to SC. Okay, so here I have the solution for part B written out in details, just in case you were not able to follow me while I spoke. So hopefully, my writing will explain everything better. Okay, moving on to part C. Notice that triangle SAB is equal to triangle SAD. So we have AH equals AK, SH equals SK, and SB equals SD. Therefore, the ratios SH over SB is equal to SK over SD. So from here we can deduce that HK is parallel with BD. Since ABCD is a square, so by property of a square, we have the two diagonals, AC and BD, perpendicular to each other. But BD is also perpendicular to SA. So therefore, BD is perpendicular to plane SAC. But since HK is parallel with BD, so we can deduce that HK is perpendicular to plane SAC. But since AI lies on this plane, and therefore HK is perpendicular to AI. And that is it for part C. Okay, that's all for this video. If you have any question or concern, please leave it in the comment section. I will be reading every comment, and I will be responding to your comment in a timely fashion. My goal is to help you enjoy solid geometry as much as possible. Thank you. Have a good evening, and I'll see you all in the next video. Thanks. Bye.